number 7. So number 7, here's what it's asking, or what it gives you. So it gives you velocity. So clearly you're given velocity there. And it's asking for the position of the particle at t equals 4. So you know that there's an integral involved in there. So you should right away know that this is not the answer. This C is not the answer, because that's differentiating. That's going to go up a step. That's going to give you the acceleration. So you know that you got to deal with this. Now, you probably maybe can throw this one out too, because that's the total distance traveled, right? I mean, the absolute value of velocity doesn't give you position. It gets, if you integrate the absolute value of velocity, you get distance traveled. So you're down to A and B. And the only difference between A and B is this pi out here. And they kind of go, well, where did that come from? That comes from the original position. So when you're thinking about this problem, what you have, the key concept of this problem is if you need, if you're looking for some amount new, that's equal to the amount old plus the integral from the old to the new of the rate. And so in this case, that's what we have. We're asked for the position at 4. We're given the position at 0. And if we integrate from 0 to 4 of the velocity, then we should get the result that they wanted us to get. And we don't have to evaluate it, we just have to write it out. That concept, this concept here, is probably tested 5-6 times on the exam. So you're going to want to make sure you know that concept. Okay, so that's number 7. Let's see where I'm going here. Just want to keep track. So I'm going to do 8, 9, and then we'll jump to 11. So number 8. So let me flip to it and get to it here. Number 8. So there's a couple different ways to do this, and I don't know the best way, but I'm going to show you how I might think about it. So you got this interval 0 to 10, and you got a particle moving along the x-axis. That just means it's going to the left or going to the right. That's all that means. It really doesn't have anything to do with this graph. Like this is not the graph of the particle. It's just, this is the graph of the particle's velocity. So you know when velocity is negative, the particle is moving to the left. So between 0 and 2, the particle is moving to the left. Between 2 and 7, the particle is moving to the right. And then between 7 and 10, the particle is moving left again. It says over the time interval 0 to 10, the particle's displacement is the change in position is 15. And the particle travels a total distance of 73. What is the total distance that the particle travels while moving to the left? So here's the way I would do this. If I'm doing this one, there's a couple different ways, and I know that you maybe go, well, all I did was subtract them and then divide by 2, and you maybe would have gotten the right answer. But here's the way I would set it up. Is I say, okay, if x is the movement left, and you know that the displacement is 15, so x plus 15 is going to be the movement right, because it had to move further right than it did left, because in order to get the displacement, we would take the movement, we would take those those things, and the two x's would net to 0, but we still have 15 more units moved to the right. Then what we would do is we'd say, okay, well, the movement left plus the movement right has to equal 73. So 2x plus 15 has to equal 73. So 2x has to equal, 73 minus 15. If you did that one, let's see, 73 minus 15, we end up with 58. And so then if you take x and you divide by 2, 58 divided by 2, and so you get 29. 29. So, some other of you guys just, right off the bat said, okay, well, 73 minus 15 divided by 2 must be my answer. And that's the right way of thinking about it. But this is kind of how I might explain it to somebody. I think I would probably jump right to this for an answer, but you get the same thing there. Okay. So that's that. So let's do number 9. And number 9 says the velocity of the particle is this. Which of the following gives the total distance traveled? So again, we've kind of talked about this a couple times with some other videos, but the total distance is equal to the integral from a to b of the absolute value of velocity. So based on that, you kind of go, oh, well, which one is this? Well, you kind of got to think to yourself, what's happening here? You know that this is a graph that's been shifted down 1. So because of that -1. So initially that the graph y equals e to the t minus 1 is going to be an exponential graph, right? It's going to be an exponential graph. But this one's been shifted down 1. So what this one is now doing is this might be an exponential graph that looks like this, where you have y equals e to the t minus 1 minus 1. So what happens is this movement is maybe to the left, and then if you go out to 3, this movement is to the right. So we can't do the absolute value, but we can do it by thinking about changing our thought process on how we might deal with this left movement by subtracting it. So when you grab the answer is this one down here, because you're going, okay, well, a way we can get around that left movement is subtracting it and then adding the movement to the right. So that's why that turns out to be the answer on that one. So you got to kind of think about what that looks like, and it does require a little bit of knowledge about that this is an exponential growth function that would look like this, and then realizing, oh, that -1 shifts the graph down, so then we end up with this kind of a solution. Okay, so that's number 9. I think the next one was number 11. I think I got 11, 12, and 13 to do. So number 11. So got this this graph here. Let's figure out what's going on with this. You got a 5-kilometer road race. The rate a runner pass a viewing stand every 16 minutes is modeled by this. So this is a rate. Okay, so again, over here in your mind, R of t is right there. It's the rate. Okay, and is measured in runners per minute. Okay, so it's measured in runners per minute. How many runners passed? Well, if this is in runners per minute, this would be in runners, and we're going to integrate to go down there, which means finding the area between the curves. So if we're trying to figure out what this is, and we're trying to do it between 0 and 16, we're just going to add up these areas. Because what we really want is we want to do the integral from 0 to 16 of r of t, which means we're going to add up some areas. And I would split this into a couple different sections here. And so we're gonna split this up, into this section right here. So we're gonna do that one's gonna be 4 times 40 plus. Now I maybe need to split this into a triangle and a trapezoid, or a triangle and a rectangle, unless you want to do a trapezoid on here. If I split this section from 40 to 10, I'm going to split that into a rectangle. So that's a rectangle 6 by 20 plus the triangle, which is 1/2. 6 times the height of that triangle would be 20. Plus, now I got to split this one right here into a rectangle and a triangle that's above it. So I would do 2 times 20 plus this triangle 1/2, 2 times 30 plus, now I'm going to do this last one, and I'm going to do a rectangle here, which is 4 by 50. And then I do have to do some calculations. I might have to go, okay, well, this is 160 plus 120 plus 60 plus 40 plus 30 plus 100, and then figure out which one it works out to be. And so you're going to have to do some arithmetic on that, and that's, if there's a free response, I'd say leave it like this top one, but this is not a free response, so you're going to have to go through and calculate those. Let me get to 12. So here's 12. So you got the area or region bound in the first quadrant. So this is clearly the line, and this is the parabola. And you have to twist your thinking on this, because when we're written like this, we're going to have to kind of twist our thinking in that what I'm going to do is I'm going to do the integral from 0 to 2, because that's a y value, and these graphs are in terms of y. And I have to kind of flip my head sideways to think, well, this is the top curve, which is 2y, minus the bottom curve, which is y squared, dy. And now I'm going to have to actually integrate this. Okay, so now I'm going to actually go through and integrate this. So this would be 2y squared divided by 2 minus y cubed divided by 3, evaluated from 0 to 2. And I have to do the math involved with this. So I'm going to do 2 times 2 squared divided by 2 minus 2 cubed divided by 3. Fortunately, the second half just is 0. So I don't have to do a ton of extra work here. But what I have here is I have 16 divided by 2 minus 8 divided by 3, and then you can finish it from there. If you finish it from there, you'll get 4 divided by 3. So that's that one. I think that you wanted me to do 13 as well, so let me look at 13. So here's 13. This is the last one, I think. So 13, let R be the region between the graphs of the natural log of x, the x-axis, and the line x equals 5. Which of the following gives the area of that region? Okay. So this is kind of a tricky one because they kind of flipped it on you and started talking about y. So let's draw a graph of what this might look like. This graph right here is y equals the natural log of x. This value right here is 1, comma 0. We're supposed to take that, the x-axis, which you kind of know is this part right here, x-axis, and the line x equals 5. Okay, well, the line x equals 5 is a vertical line here. And so the region we're talking about in this is this one right here. Whenever it says bounded by these things, you're kind of think of those as fences. So that's the region we're talking about. Well, in this case, you would have loved it if they had said, oh, what is that? And you'd have said, oh, that's the integral from 1 to 5 of the natural log of x dx. And I'd say, yeah, you're exactly right, but that's not the way they presented it to you. So what you have to do is think about this in terms of y because of the way they presented it. So here's what you got to do. You just got to go, okay, well, if this is x, if y equals the natural log of x, e to the y is equal to x. And if you think about, what this looks like, we're going to do the top curve, which is 5, minus the bottom curve, which is e to the y. And we're going to do dy on this. But in order to do that, we got to use the bounds on this part of the axis. Well, those bounds would be from 0 to this x equals 5. Well, when x equals 5, y equals the natural log of 5. So up here, this is the natural log of 5. So that's where we're going to have the natural log of 5 here. And so that's where, if you look at the solution, that's the solution you have, and that's what I wrote there. You kind of change your thinking. So this was a little tricky. Those problems were a little tricky in that you got to be able to adjust your variables and flip-flop variables and be able to work with those. But this is the way I would have tackled 13. Hopefully that makes sense to you. And if you have any further questions, just let me know.